All right, we this morning are going to do some exploring. So, you put your name on it. We're going to do some exploring today with investigating rational functions as our ultimate goal. But we're going to do some work with some functions that appear when you just get this down and see the picture of the graph. What kind of functions family do they appear to be? Here, you know that. Sweet. So I've got some graphs in front of you that are linear, at least on the first page. If you glance through, though, you'll see that they're not all linear. Our goal this morning is actually to start by doing something that's quite simple. Everyone here is capable of multiplying. Multiplying numbers, either in our head or with our calculator. We're going to look at multiplying two functions together and see what happens. So earlier this year, we talked about quadratics and the fact that when I multiply two lines together, two binomial factors together, they FOILed and they came up with a quadratic function most of the time. We're going to do that same kind of idea here. I want you to look at what's going on because there's a lot of notation. So here's our Algebra 2 advanced notation. It says right here in the middle, f of x equals 2 and g of x equals x. Then it says, let h of x equal f of x times g of x. So if I take f of x, which is 2, and I multiply it by g of x, which is x, I get 2x. So really, h of x is equal to 2x. We are going to think through some different multiplication problems to figure out some points on the equation for 2x. We're going to do it a little bit differently. But first, what I want you to think about is if h of x is 2x, what would be h of negative 2? What would happen if I plugged negative 2 into this function? 0. I would be multiplying, not adding. I'd get negative 4. Okay. What about if I plugged a 3 in?
6.
Okay. Would it be like 4x? Negative 4x?
You're plugging it in part.
So this is a 6. Oh, it kind of looks like a B. 6.
I thought that was a B. I'm like, you just said 6 and you said it was right. Why did you put B there?
Okay. So if you can do that math, how many people can do that math? 2 times 3? Because negative 2?
Oh,
If you can do that, oh yeah, it almost doesn't feel like it. If you can do that math, you can do what we're doing today. Good news, isn't it, Billy? Good news, isn't it? You can do that. You can do everything we're doing today. Okay, here's what I want you to look at. Your job this morning is to do what you just did, basically, for all of the different points. But I want us to actually investigate this and think about how we could go about it a little differently. Instead of plugging numbers in over and over and going into an equation, I want you to look at where those numbers come from. So I have two graphs that are done for you that are labeled F and G. One of them is the graph of y equals 2. The other one is the graph of y equals x. But I actually don't want you to think about equations at all today. All I want you to do is think about numbers and how they multiply. Do that? Yes. So the way that we're going to create this graph over here called h of x is actually not by using an equation. We're going to use points and multiply them together. I want you to think about doing this. It's a little different than what we normally do, but I want you to think about doing this and how it helps us understand how the graph is actually made. So what I want you to do is I want you to look above the number negative 3 on the x-axis of the graph that says f, and I want you to tell me how high it is. It's too high. Now I want you to look at the G graph at the same x location, negative 3, and I want you to tell me how high the line is.
Negative 3.
Okay. I want you to multiply together the two heights, 2 and negative 3.
Negative 6.
Okay. I get a negative 6, so I want you to go to h, which is supposed to be f times g. Since you just multiplied f times g together and told me negative 6, I want you to go to the same x location, -3, and I want you to put a point at -6.
Wow.
I thought you'd be averaging on that.
No, I did the same thing to the other one.
Now we're going to go to -2, and we're going to say how high is f at -2?
2.
Too high. How high is g at -2? So I have +2 and -2, which makes -4. So at -2 on the h, I'm going to go down here to -4. And then I'm going to do it again. I'm going to go to -1 this time. At -1, how high is f?
2.
How high is g?
-1.
So what is 2 times -1? Good. Guys are great little multipliers.
We just keep on going all the way up.
We're going to go all the way across. So
Just go up over to this time.
how high is f?
I said it's the same thing.
2. How high is g?
0.
What is 2 times 0?
2. 2. 0.
Multiply?
That's 3 times.
I just was getting so scared. It's multiplying. We go all the way across the graph. We're looking for a pattern. The next point is where? So let's investigate. Does that really work? This would be 2 times 1, which would give me 2. So he's right. It goes up 2 and over 1. Now, I want you to not think about the equation, but if for a second you thought about it, what was the equation that we wrote down at the top? 2x, which has a slope of up 2 over 1. That's where that comes from. So you're right, if I did it one last time on here, or actually 2 last times, I'd have 2 times 2, or 4. And then lastly, I would have 2 times 3, or 6. And so when I get done with this, I draw a line going through the points. I feel fairly certain that that pattern would continue forever and ever, which is why I threw arrows on both ends. Flip your page over. We're leaving the world of linear, though. So I had you do that one and look at a graph that made a line that you figured out a pattern for. Now we're going to leave 2 linear functions, and we're going to look at a linear function and what shape is that second one? Okay. And we're going to do the same thing, though. We're going to multiply. Now, some of these points may or may not be perfect. We're going to do the best we can to multiply as much as possible. So I start here and I go to graph. The first one has a -3 with what? How high? Okay. How high is the next graph?
Like 7. I'd say 7 or 8.
Do you know for sure?
No.
Okay. For right now then, since we don't know for sure, we're going to leave it alone and we're going to just go to the next point because we can't see how high this one is. We just know it's somewhere up here. So I'm going to leave it alone for a second because we're going to try to find a pattern ultimately. How high is it at -2? And how high is this one at -2? Okay, so we can do that one. What is -2 times 3?
-6.
So I'm going to go over here at -2 and match up to -6. Now I'm going to do the next one. What?
You got 2 5s on there. So it's 6.
What are you talking about?
On the papers, they got to cut off.
Instead of 6, it's a 5.
That's a 6.
There's a 4, 5, and 5.
Yeah, on the paper, on this bill.
Oh my gosh,
On the
what's
paper,
that?
it got cut off a tiny bit. So
Oh, it looks like a 5. It says, oh, I was going to say it.
It's obviously line under 6.
Okay. It totally looks like a 6 on mine. Okay, so now the next point, -1, how high am I?
2.
-2, and then I'm at 0. So what is that when you multiply them?
0.
So at -2, I'm going to, or -1, I should say, I'm going to put it at 0.
Wow.
And then, yeah, it did jump huge. And then I'm going to go, how high is it at 0?
-2.
And how high is it at 0 here? What is -2 times -1?
Or 2.
Positive. Okay, we're going to do the next one. How high am I here?
-2.
You messed up second.
How high am I here?
1.
-2 times 1. -2 times +1
-2.
is -2. Oops.
No. You're at 0. You're not at 1.
I just did 1 and 1, so I should be at what?
That's not 1,
It's
that's 0. On the parabola,
On the parabola, it's 0.
that's 0.
Oh, this is 0 high.
0.
I'm doing
I was so
y.
confused what you were doing.
I didn't do the height. Okay.
Doing y.
Jordan and I went down the
Yeah.
wrong path. Okay. So at 2, how high is it?
-2.
At 2, how high is it?
3.
What is 2 times -3? Okay. Aaliyah, were you right with your prediction?
Yes.
And the next one, it does go off the screen on the G function. Although this here is -2, I'd have to make a guess up here. My answer, though, if I do a negative times a big positive, is going to end up negative. It is going to go off the graph somewhere down there. I feel pretty good about Aaliyah's prediction. I'm going to draw a curve, not a line.
It happens once in a while.
Happens a lot. What do you think we should do down here?
Do the same thing.
Okay, so we're going to start out the same way. My very first point, how high is -3?
1. -1.
Okay, so I have to do -1. How high is this graph at -3?
Nothing. 0. There's nothing. It's not possible. Because it's not a 0, so there's no line there. It starts at 0.
There's nothing there. So what is -1 times nothing?
Nothing. There's just 1. It doesn't exist anybody.
Imaginary?
Error.
So what should I graph?
Nothing.
Okay.
In volleyball.
How high is it at -2? Nothing. Okay.
We just started.
Why would you just start at 0?
There's nothing going across there.
Until that one, so if we have to have a number to match, you're saying the first time a number matches would be to do this one times this one.
Yes.
And what would it give me?
0.
Okay.
So you have nothing.
And then I have -1 times
1.
1. Okay.
Let's do the other half of that perhaps.
And then I have -1 times. Ugh.
Wait a minute, you just did it.
I'm trying to do 2.
Half.
We just need to estimate and decide.
It looks like 1.5.
About 1.5?
Yeah.
So what I would do, and what you're going to be doing in just a second, this is the last one we're doing together. So what I would do is I would just make an estimate. And if I wasn't sure how to multiply, now -1 times 1.5 is pretty easy to do in our head. But if it would have been like a 2 or a 3 or something that we couldn't multiply, just grab your calculator, estimate. So you're guessing that it's -1 times 1.5, which would give me -1.5. So I'm just going to estimate and put it down there on my graph. And I do the same thing with my very last point. Again, estimating. This is -1 times, I don't know, 1 point what?
1.875.
7.5, 8, 9. We're going to be estimating. Probably it's going to look pretty close, even if you type in times 1.75 or times 1.8. Either way, I'm going to be pretty close to negative this region. Once I get done, my job is to connect in a smooth curve. Caleb, were you right? with your prediction? Yeah. Said it was the other half. That's what I pictured when you said that. What questions do you have about this process?
What's the guess?
What did you have to do?
What you have to do is you now have to take a look at problem 3. So start glancing ahead. So, because I said what kinds of questions. 4 looks scary.
Where would you graph that at?
What are you gonna do though when you don't know how high something is? You're just gonna guesstimate. So you're gonna do number 3 and number 4, and then lastly you're gonna do number 5. So numbers 3 and 4 and 5. You're gonna do them. Listen to this. You're gonna do them in the next 15 minutes. All of these, those 3, numbers 3 and 4 and 5. Yes, ma'am. What's up with these circles? Ooh, where are you looking?
Rounding 3 and 4. Them circling things right there.
Okay, the circly thing. Good question.
Maybe they go around that.
Because you're going to have, it kind of is. So the circly thing, on the graph, the line is supposed to indicate all the points. So, like for example, when I'm right here, how high is this graph?
1.
Okay. When I'm right here, the graph is still up 1. When I'm right here, the graph is 1. This circle right here is like, it's what we call a hole in math.
There's no point.
There's actually no point right here. So it's this spot right here is not up 1. It's kind of like back here on our graph when you told me that, oh, where was he? Down here. When you told me that this graph didn't exist.
Oh, so that doesn't exist?
It actually doesn't exist right there at that little hole.
Would you make
So
a
so think about what to do when you get there. That would mean, yeah, it's like a puzzle.
So if you draw a hole on your
That would mean it's something that doesn't exist times a number, which means it doesn't exist on your on your next one.
Why?
Yeah, you could do that. It's true. We're going to talk about that.
Yeah, but like, that doesn't make people think it's harder.
Done. I want you to look at number 3. When you did your number 3, we talked a little bit about this before you got going, but we talked about that hole. I want to know what you guys came up with. As far as your line goes, when I was walking around, I saw a lot of people with good starts to lines. I saw this on a lot of people's papers.
So if x equals 1, then the graph is the same, right?
If x equals 1,
The far left, x equals 1 is the graph, right?
actually that would be y equals 1.
Y equals 1.
But that would be y equals
Put a
1. That's
circle
true.
on the one.
Yeah, people dealt with that problem differently. I saw some people stop here, which is good. What else did we decide to do? You said you put a circle at the 1?
Yeah,
Okay. What did you do?
I put the circle at the right position.
Why does that kind of make sense here with what we're doing? If I want to connect them, like right now I can connect these. And I can connect these.
Lines are like the same thing, but there is a circle itself.
Yeah. Yeah. So when we see these graphs, guys, I can't be having yellow in that game. Put it away.
Put it in like that.
So when these graphs right here look like a trend and your goal is to connect them all and make a single trend, you can see they're supposed to pass through here. But Aaliyah's saying she knew it didn't, so she added this bubble here. Notice that this little circle here was at a height, it just didn't exist there. So you could think about it still as 1 times 3, knowing it should be at 3, but because it doesn't exist, it just doesn't exist there. So if you didn't already do that, I do want you to add that. The one with the most problems probably is this one. You had 2 bubbles, plus you had something weird happen right here in the middle. But Hunter's noticing, he says it should look pretty much like the same graph because he was always multiplying by this line, which is 1. So if I'm graphing times 1 every time, it should look the same as what's in the second graph, except for the fact that I would have this bubble at -2, which would mean you should have had a graph that had a good dot here. You had a good dot here. I would have also seen, let's see, a good dot here and a good dot here. But circles could go in the other spot. So if you think about 1 times this, that would mean I could estimate it here, but put it in as a bubble. And same thing here. This is a bubble, but it's at the height of 1 times 1. So at the height of 1 times 1, I would have a circle or a bubble. We call them holes because they don't exist. They help us to see a trend. Now, this graph doesn't have a hole at 0. I've got a height of 1 times this line right here. There are no points on it. Furthermore, if you follow the pattern, it could be crossing through, it seems like, way down here or way up here. So that graph literally does not seem to exist there. What did you guys do with those dots?
I drew it anyway.
You drew it, you made it a circle where?
Right where you went. Where the line is.
Like here?
Where the dots are.
Here?
No, on the x-axis. We do,
Right here? Like that?
No.
You mean you're talking about this circle that I drew? What'd you do at 0 though?
0.
I just didn't do anything.
You just did
I
nothing?
just wrote the graph like it was on that one right there.
So you drew it like this.
Yeah.
So you actually drew yours like this.
Yeah.
Yeah.
Oh, sweet.
Because since it's 1, I just assumed that everything would be the same. I didn't draw those dots though.
Okay. Add the dots in if you didn't already, but you're right about the shape of the graph. It should look the same. It just has these little dots now, these bubbles, where it doesn't exist. Okay. We're thinking about why these occur and when these occur and how to get the graphs to look like this. So now I'm going to add one more small challenge for us this morning before we're going to be done. The second challenge is, we're not going to do all of this, but we're going to start out with a couple of problems that now say instead of multiplying, you're going to divide. Which might mean we need our calculator, but it doesn't mean we don't know how to do it. It just means we're going to need to divide to get our answer. Make sure that you do it in the right order, though, because you know that dividing backwards gets you wrong answers. So you have to go from left to right. So if we do the same thing, we ask ourselves, how high is this graph? And how high is this graph? You need to type in or do in your head -1 divided by -2.
Positive 1/2.
You did it backwards. It's 1/2. Those of you who said 1/2. 1 divided by 2 looks like this, which is not the same as 2. Yep, you have to do, so -1 divided by -2 is what we were doing, which is positive 1/2. So I would be putting a dot approximately at 1/2. Then, how high is this one? Okay, he's 0 divided by, how high is this one? What is 0 divided by -2? 0, so I put it at 0. Then I go, how high is this one?
1.
So I have 1 divided by, what is 1 divided by -2?
It's a negative half.
So I'm going to go at -1/2. We're almost there. How high is this one? Divided by 2 divided by -2? Whoops.
Negative 1.
It's -1.
I'm seeing a pattern.
You're seeing a pattern, which means you should know where this one goes. 3 divided by 3 divided by -2.
Negative 1/2.
-1/2. If you didn't know that, you could have typed it in, but you also might have noticed the pattern. You think that one's going to be at -2? Absolutely is, because it's 4 divided by -2. And you're right. He's going to end up right here. So then I'm going to say, hey, this one's making a line. I'm going to draw my arrows through. There's a reason we're trying to explore this, because I said today that our goal is to investigate something called a rational function. So we're trying to investigate what a rational function looks like and how it gets created. What I want you to do today, your last goal, which you're going to turn this in before you leave so I know you did it. Those of you who had done nothing. Your goal, before you leave, to turn in is you're going to do what we just did with division on problem number 1 on the next page and problem number 2 on the next page. And that is it.
Are they just flat?